for the solution video. In this video, I am going to deal with the equations portion of this worksheet, which starts down here on page 2. So you're given a whole bunch of log or exponential equations, and you're asked to solve each one for x. So in this first one, we only have one x in the problem. So to solve for it, we just have to isolate it. And to isolate it, I'll start by adding 5 to both sides of the equation. Negative 1 plus 5 is positive 4. Then I'll divide both sides of the equation by 2. 4 divided by 2 is 2. And then to get rid of this log base 3, I will do 3 to both sides of the equation. So 3 to the log base 3 of 4x plus 1 is just 4x plus 1. And 3 to the second power ends up just being 9. So if 4x plus 1 equals 9, then 4x must be equal to 8 if you subtract 1 from both sides of the equation. And once you divide by 4, you get that x is equal to 2. That's the solution to this one. This next one's similar, I guess, in that it only has one x. However, now instead of the x being down here, it's up in the exponent. That'll cause a little bit of trouble. We'll cross that bridge when we get there. Start out solving it kind of the same way. Want to isolate that x, so let's get rid of this negative 5 here by adding 5 to both sides of the equation. Three plus 5 is 8. Divide both sides by 2. And now I want to get rid of this log base 3, so much like I did up here, I'm going to do 3 to both sides of the equation. So 3 to this side of the equation will leave me with just 4 raised up to the 3x minus 1 power plus 17. And on this side, I'll have 3 to the 4th power. Turns out that 3 to the 4th power is 81. So if I want to isolate this x, let's get rid of this 17. Subtract 17 from both sides of the equation. See, 81 minus 17 is 64. So now if I take the log base 4 of both sides of the equation, I get 3x minus 1 is equal to the log base 4 of 64. Log base 4 of 64 is just asking what power must you raise 4 up to make it a 64. Well, 4 to the 3rd power is 64, so this is just 3. Add 1 to both sides, divide by 3, you get x is 4/3 as your solution. Moving on, this one, a bit more challenging, I guess, because I have multiple x's in the problem. One way you can deal with that, there's a lot of different ways you can solve this. You could take the log base 3 of both sides, although you'll have this 5 to deal with. It'll be a bit of a pain. You can take the natural log of both sides, but you'll still have that same problem. A little trick, I guess, that you can do is divide both sides by 3 to the 2x power. Might not be obvious why you're doing that at this point, but it's just a way for me to show you how to do this problem. What I have on the right side of the equation is when you have the same base and you're dividing, you subtract the two exponents. So really I can rewrite this as just 3 raised up to the, whatever the difference in those exponents is, x plus 2 minus 2x. But that simplifies a little. I got 5 is equal to, if you have 1x and you take away 2 x's, now you have negative 1x. So I get to here. And now you want to solve for x. So to solve for x, you got, whenever you need to get the x out of the exponent, you want to take a log of both sides. Take the log base 3 of both sides, log base 5 of both sides, natural log of both sides, doesn't really matter. Maybe I'll take, I don't know, log base 3 of both sides. If I take the log base 3 of both sides, I'd have the log base 3 of 5 is equal to 2 minus x. So if I add the x over here and subtract the log base 3 of 5 over there, I get that x equals 2 minus the log base 3 of 5. Note here, you could do this problem differently if you felt like it. If you wanted to just take a log at the very start, you take any log you want, maybe the natural log, why not, of 5 times 3 to the 2x. That would be equal to the natural log of 3 raised up to the 3x plus 2 power. Dang, I missed that throughout the problem. Bummer. Okay, I thought it just said x plus 2 here, but it didn't. It said 3x plus 2. So this should be a 3x, and this should be a positive x, and this should be a positive x, which means that for my solution, I would want to subtract 2 from both sides of the equation, and so it ends up like this. Guess I kind of save things. Anyways, back over here, maybe I should have made a new video, but I'm busy. I got stuff to do. I took the natural log of both sides so that I could deal with the exponents. I can move this exponent down in front. I can make this 3x plus 2 times the natural log of 3. However, I can't take this 2x and bring it down in front because I'm not taking the natural log of something to the 2x. I'm taking the natural log of something times something to the 2x. So I have to first apply my first log rule to rewrite this as the natural log of 5 plus the natural log of 3 raised up to the 2x power. And then I can bring that 2x down in front to get to here. And I'm not done yet. I haven't gotten way over here, but now I have a linear equation. I don't have anything up in an exponent, so I can solve for it. Maybe distribute the natural log of 3 through, and you get the natural log of 5 plus 2x natural log of 3 is equal to 3x natural log of 3 plus 2 natural log of 3. You take this natural log of 3 and distribute it through. And then if you get all the x's on the same side of the equation, by subtracting this 3x natural log of 3 term from both sides, and subtracting the natural log of 5 from both sides, you can factor out an x, or I guess you don't even have to factor out an x, you can combine like terms. I have 3x of these things, I have 2x of these things, I'm taking away 3x of them. I'm left with negative 1x of them. And so if I divide by the negative of the natural log of 3, I get that x is equal to 2 natural log of 3 minus the natural log of 5 divided by the negative of the natural log of 3. It turns out that this is equal to this. How do you know that's equal to that? Well, it has to be. There's one reason I know, but you can almost see it if you write 2 natural log of 3 divided by the negative of natural log of 3. The natural log of 3's would cancel out and you'd be left with negative 2. That's this negative 2 right here. And then you have the negative of natural log of 5 divided by the negative of natural log of 3. Those two negatives cancel out, so I get a positive. And if you apply the change of base formula right here, you get exactly this. There's two different ways to solve part C. I probably shouldn't do that because this video is already too long. Maybe that's beneficial. This one, I'm just going to solve this one way. I'm going to do this a lot like what I did over here. You don't have to take the natural log of both sides. If you wanted to take the log base 6 of both sides, you could do that. Log base 6 of 2 times 3 to the 2x is equal to the log base 6 of 6 to the x. That's just x. You apply your first log rule to rewrite this as log base 6 of 2 plus log base 6 of 3 raised up to the 2x power. Then you apply your third log rule to take this 2x down in front, and you get the log base 6 of 2 plus 2x times the log base 6 of 3 is equal to x. And now you got a linear equation, you want to solve it for x. You got an x here and an x here. So get all your x's on the same side of the equation. Maybe subtract this over to this side. And you get that the log base 6 of 2 is equal to x minus 2x log base 6 of 3. If you factor out an x from each of those terms, you get x times 1 minus 2 log base 6 of 3. And now you divide by all this stuff to get that x is equal to the log base 6 of 2 divided by 1 minus 2 times the log base 6 of 3. You could rewrite this. You could write this in lots of different forms. I'm not going to bother. Here's one form that your answer could look like. I guess I should put boxes around these other ones so it's a little bit more clear where my answers are in this huge mess of colored math. This problem looks miserable. It's really not that bad once you kind of get the hang of it. So the idea here is to there's only one x, so you got to isolate it. To isolate it, I got to get rid of a whole lot of stuff. So just kind of start chipping away at it. I can get rid of this log base 2 here if I do 2 to both sides of the equation. 2 to this side of the equation, the 2 in the log base 2 would cancel out, and I just have the log base 3 of the log base 4 of 3 times 5 to the 4x minus 10 power minus 11. And that's equal to 2 to the 0 power, which is just 1. So I can get rid of this log base 3 equals 1. Maybe that's bad. I don't know. How about this? So I can get rid of this 3 by doing the same thing. Do 3 to both sides of the equation. Now you got the log base 4 of 3 times 5 to the 4x minus 10 power minus 11 is equal to 3 raised up to this side of the equation, 3 to the 1 power, which is just 3. Okay, and from here we can get rid of this 4 by doing 4 to both sides of the equation. So maybe I'll pick it up here. 4 to the log base 4 of stuff is just that stuff. The 4 and the log base 4 cancel out. And on this side of the equation I have 4 to the 3rd power. It turns out 4 to the 3rd power is 64. So now if I add 11 to both sides of the equation, I got 3 times 5 raised up to the 4x minus 10 power is equal to 64 plus 11, which is 75. Divide by 3, you get 5 to the 4x minus 10 power is equal to 25. Take the log base 5 of both sides of the equation, and you get 4x minus 10 is equal to the log base 5 of 25. So 4x minus 10 is equal to 2. Because the log base 5 of 25 is just 2, since 5 to the 2nd power equals 25. Add 10 to both sides, and then finally divide by 4, and you get x equals 3 for your solution. Okay, this was modeled off a homework problem because the homework problem is pretty challenging. What you want to do here is you can use your second log rule up in the numerator here and rewrite the numerator as the log base 2 of x to the 7th power divided by x to the 3rd power. However, it might look like you could apply a log rule with this division here, but you can't. But what you could do is multiply this log base 2 of 2x over to the other side and make it 3 times the log base 2 of 2x. So I guess I did 2 steps there, which is kind of bad form. I used the second log rule in the numerator here, and I multiplied both sides of the equation by the denominator so it cancels out here and shows up top here. And now what I'm going to do is recognize that x to the 7th power divided by x to the 3rd power is x to the 4th power. And I can take this 3 using my third log rule and bring that up into the exponent. So I get the log base 2 of 2x to the 3rd power. Note this entire 2x is raised up to the 3rd power. Log base 2 in both cases, that's nice. I can get rid of those log base 2's if I do 2 to both sides of the equation. It gives me x to the 4th is equal to 2x cubed. So x to the 4th is equal to 8x to the 3rd power. 2x times 2x times 2x is 8x cubed. Divide both sides by x cubed, and you got to be a little careful there. One solution happens when x equals 0. This is the same as this. But actually x equals 0 is not a solution, because if you plug in x equals 0, you'll be asking what is the log of 0, which is something that's undefined. So we don't have to account for the fact that x equals 0 is a solution, so I can divide both sides by x cubed and get x to the 1st power is just equal to 8, and this will give me the solution that works. Okay, moving on. Another equation. The challenge with this one is I have 2 different bases, although I've seen some problems kind of like that. I need to get stuff out of the exponents. Take the log of both sides. Which log? I don't care. Natural log, why not? That's as good as any. The natural log of 2 raised up to the 2x power is equal to the natural log of 20 raised up to the x minus 1 power. I can now apply my third log rule twice. Over here to bring the 2x down in front, and over here to bring the x minus 1 down in front. I got all my x's out of the exponents. That's good. I have 2 x's floating around. That's bad. What I'll want to do eventually is factor to get a single x, but it's hard to do with these parentheses here. So I'm going to get rid of these parentheses by distributing that natural log of 20. 2x natural log of 2 is equal to x natural log of 20 minus the natural log of 20. And now I can get all my terms with x's in them on one side of the equation. Maybe I'll move the natural log of 20 over to the left side, and I'll subtract this over to the right side to get x natural log of 20 minus 2x natural log of 2. And so finally I can factor, I guess not quite finally, almost finally, I can factor out an x from each of those terms. I got the natural log of 20 minus 2 natural log of 2. So x is equal to the natural log of 20 divided by the natural log of 20 minus 2 times the natural log of 2. Perfectly good answer right here. Can you simplify that? Well, you can write it in different forms. You could argue about what's simpler. But for G, I'm going to leave my answer here because H tells me to simplify that answer, essentially. It tells me that I can rewrite this, I don't know, down here, I guess, as the natural log of 20 divided by the natural log of 20 minus the natural log of 4. Where'd that 4 come from? I took this 2 right here and I moved it up into the exponent using my third log rule. 2 to the second power is 4. Now I got the natural log of 20 divided by the natural log of 5. Where'd that 5 come from? Well, I can use my second log rule that says if you have the natural log of something minus the natural log of something else, you can rewrite that as the natural log of the quotient of those two things. That gets me here. And now I can use my change of base formula to say that this is the log base 5 of 20. Which is the form it wanted it in. All right, 2 more. Whew. This one, there's a trick to this one. These last 2, stop the video here, I guess, because I'm not going to test you on these last 2, except maybe for extra credit or something. We haven't gone over the substitution method in class. However, this is how you do it. I can rewrite this as 3 to the x minus 1 power squared minus 12 times 3 to the x minus 1 plus 27 equals 0. Because if you have an exponent to an exponent, you multiply those two things, and 2 times x minus 1 is 2x minus 2. You could write it like this. Why would you bother writing it like that? Because then I can do this substitution. Everywhere I got a 3 raised up to the x minus 1 power, I can just write some letter like y. Call it y squared minus 12y plus 27 equals 0. And this is an equation you can solve by factoring. You could say this is y minus 9 times y minus 3 equals 0. So either y equals 9 or y equals 3. So that's my answer, no, because y is something you just created. Right? Y is this 3x minus 1 thing. So really, I'm trying to solve for x. So instead of y equals 9, I should say 3 to the x minus 1 equals 9. Or 3 to the x minus 1 equals 3. Take the log base 3 of both sides of the equation here, you'll get x minus 1 equals 2, so x equals 3. If you take the log base 3 of both sides of the equation here, you'll get x minus 1 equals 1, so x is equal to 2. So these both end up being solutions to this problem using this substitution method. Last problem. This one's similar. Although it doesn't quite fit this quadratic form yet, we're eventually going to substitute. Everywhere we see a log base 2 of x, we'll change it into a y. But this squared right here is causing trouble. It ruins my substitution. But I can use my third log rule to say this is the log base 2 of x squared minus, I can bring this 2 down in front. Note the unnecessary parentheses there to really emphasize what's going on with my substitution. The thing inside the parentheses is changing into a y. So I get y squared minus 2y minus 8 equals 0, which I can factor as y minus 4 times y plus 2 equals 0. So either y equals 4 or y equals negative 2. Those aren't your answers because y is this log base 2 of x thing. So it's really the log base 2 of x that equals 4, or the log base 2 of x equals negative 2. I can solve these equations for x by doing 2 to both sides of the equation. On this side I just have an x. On this side I would have 2 to the 4th power, which is 16. On this side I just have an x. On this side I would have 2 to the negative 2 power, which is 1/4. So when I said answers should be whole numbers, I lied. Answers should be a whole number and a fraction. Sorry about that. Alright, that finally ends this video. So I'll quit this here.